Hi there, welcome back, and in this particular video I will show you how to convert a given binary number into a decimal number. So let's quickly start off with that. Let me write one simple binary number 11100011. So that is a very simple binary number. I want to convert this into a decimal number. That means a number that the humans understand. I'll just write humans here. And this is the number that the computers understand. So what do I do in this case? In the previous example you saw that to write the powers of 2, so I will write the powers of 2 again, basically 2 to the power 0 again. Remember from the last video, you have to write the powers of 2 from the right hand side. Always write it from the right hand side, so that when you write the binary digits it makes it very easy for you to work with. 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6. So in this case you just have to write these powers of 2 below these binary values. Alright, so I'll just do that. So you write 2 to the power 0 is basically 1, 2 to the power 1 is basically 2, next value will be 4, 8, 16, 32, 64. So I stop at 2 to the power 6, that means my estimate was correct. I will go up to that value. Now from these values you just have to add the ones that have got bit 1 above it, so that will be 64, right, and 2 and 1. So these are the ones you're going to add. 64 plus 32 plus 16 plus 2 plus 1. When you add all that, see what value you get, and that will be the decimal equivalent. And decimal equivalent you denote it with the base 10, so you get 115, 115. So this value, this binary value was representing 115. So you can try a very simple notation here. Let's say 11111. In this case, what will that be equal to in binary? In very simple terms, this is 1, 2, 3, 4, 5. So you just write 2 to the power 5 minus 1. That is the max binary. And the max decimal will be 32 minus 1, which is 31. So now if you want to add and check whether what I've just explained is correct or not, you write 1, 2, 4, 8, 16. When you add all this you will get 31. If you want to check, 16 plus 4 is 20, 28, 30, 31. So that matches. So you can use this small formula. If all the bits are ones, then you can use the shortcut formula, which is 2 to the power n minus 1. That is the value you will get, and this is what we call a max, the max value. Alright, that is the max value that can be represented with a, in this case, a 5-digit binary. So if I have 1, 2, 3, 4, 5, 6, 7, 8, the max value that I can represent over here is basically 2 to the power 8 minus 1. So that is 255. And I'm sure you've heard of this number before. So I hope you can recap this and watch later. Okay, I'll show you how I'm assessing these particular videos. That these videos are assessed in both formative and summative ways. So in this particular case, these particular conversions are assessed in the form of the binary quizzes, as well as the MST paper, as well as the so under fundamentals of computers, the students have the quiz one, which says binary conversion. So if you look at this quiz, this is basically on binary conversions, and this is how the students are assessed, and they are given 2 attempts, of course, for the quiz. And the paper is also here, and in MST paper format. If you can just quickly have a look at it, in their MST paper, one of the topics that is of course covered is their binary conversions. So this is how they are assessed in a very formal way. And in the final exam they have a similar type of question, just to ensure that they really have grasped these concepts. Alright, thank you so much for watching.